welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the ISC Squared CISSP exam with focused explanations and practical context. In this episode, we'll explore SCADA systems and embedded system security, two critical areas that demand specialized attention due to their unique roles in industrial environments, infrastructure management, and operational technologies. These systems are often overlooked in conventional cybersecurity strategies, but play a vital role in national security, public safety, and business continuity. As a future certified information system security professional, you need to understand how to secure both SCADA and embedded systems, with the appropriate techniques, tools, and architectural consideration. Let's start by examining SCADA, which stands for Supervisory Control and Data Acquisition. SCADA systems are used to monitor, control, and automate industrial processes. They are a key part of operational technology environments and are commonly found in sectors such as electricity, water treatment, oil and gas, manufacturing, transportation, and agriculture. A typical SCADA system includes several components. First are supervisory computers that monitor and gather data from across the system. Then there are programmable logic controllers, often called PLCs, and remote terminal units that interface with field sensors and control valves, pumps, motors, and other industrial machinery. Human major interfaces allow operators to visualize the process and make manual adjustments as needed. Communication networks, sometimes spanning vast geographic areas, connect all of these elements together. SCADA systems are critical because they control essential infrastructure. If a SCADA system fails or is compromised, the result can be widespread disruption. Water systems could overflow or shut down. Electric grids could black out entire cities. Pipelines could leak or explode. The stakes are high, and that means the security of these systems must be approached with rigor. However, SCADA systems were not designed with modern cybersecurity threats in mind. Many were deployed decades ago and used legacy hardware and proprietary protocols. These systems often lack authentication, encryption, and audit logs. Even basic patches and updates may be difficult or impossible to apply without disrupting critical operations. To secure SCADA environments, organizations must adopt security measures tailored to industrial contexts. Network segmentation is essential. The SCADA network must be separated from the business IT environment, with strong firewalls and tightly controlled data flow between them. This helps prevent lateral movement if the corporate network is compromised. Access to SCADA components should be strictly controlled. This includes using strong authentication for both local and remote access, limiting privileges based on roles, and disabling unnecessary services. Remote access, in particular, must be protected with secure tunnels, multi-factor authentication, and monitoring. Encryption should be applied wherever possible, including communications between field devices and control centers. While some legacy protocols may not support encryption, newer solutions or security gateways can help add secure wrappers around older systems. Now let's shift to embedded systems. These are specialized computing systems designed to perform dedicated functions, often within a larger mechanical or electronic system. You can find embedded systems everywhere, from medical devices, automobiles, and industrial machines, to consumer electronics, smart home devices, and sensors used in the Internet of Things. Embedded systems present unique security challenges. They often operate with limited processing power, memory, and storage. This makes it difficult to use standard antivirus tools, full-scale encryption, or traditional patching systems. Many embedded devices are also deployed in the field for years, sometimes decades, and may never receive a firmware update after installation. These limitations make embedded systems attractive targets for attackers. Compromising an embedded system could allow an adversary to spy on users, disrupt operations, or pivot into larger networks. A vulnerable insulin pump or pacemaker could present life-threatening risks. A compromised car controller could endanger passengers. A hacked industrial controller could sabotage production. Effective embedded system security begins with secure development. Manufacturers must implement secure coding practices, limit exposed services, and disable unused interfaces. Components should be designed to boot securely, verify firmware authenticity, and resist tampering. Devices should log critical events and protect stored data. Authentication is critical. Devices must authenticate users and other systems before accepting commands or sharing data. Default passwords must be changed during deployment, and hard-coded credentials should never be used. Updates must be managed securely. Devices should support secure, authenticated firmware updates. If over-the-air updates are used, they must be encrypted and signed to prevent attackers from injecting malicious code. In some cases, physical access may be required for updates, and organizations must have clear procedures for safely applying them. Let's now look at best practices for implementing security across both SCADA and embedded systems. Start by clearly documenting your policies. These should define how devices are selected, deployed, managed, and retired. For SCADA, include guidance on network segmentation, operator access, change control, and remote access. For embedded systems, focus on secure coding, configuration, update policies, and supply chain integrity. Network segmentation is one of the most effective defenses. SCADA systems should never be exposed directly to the internet. Embedded systems, particularly those that communicate with cloud services, must be monitored for unusual traffic patterns. Firewalls, proxies, and application layer gateways can help control and inspect communications. Authentication and encryption must be enforced. Communications between SCADA components or between embedded devices and central servers should be encrypted using secure protocols. Devices must verify the identity of peers before exchanging data. Sandboxing and application whitelisting are useful in embedded environments. These techniques ensure that only approved code can run on the device, reducing the risk of malware or unauthorized changes. Regular assessments are essential. Conduct vulnerability scans of SCADA networks and embedded devices. Use penetration tests to evaluate access controls, protocol handling, and system behavior. If live testing is too risky for operational systems, consider building a test bed that simulates the environment safely. For more cyber content and books, please visit cybersatter.me. You'll find bestseller books, training tools, and resources tailored specifically for cybersecurity professionals. You can also find more CISSP episodes and support at baremetalcyber.com. Let's now examine security controls that are specific to SCADA and embedded systems. Intrusion detection and prevention systems must be tailored to these environments. Industrial systems generate different types of traffic and operate on different schedules compared to IT networks. Use tools that understand industrial protocols and can identify anomalies in command sequences, timing, or data flows. Endpoint security is also important. While traditional antivirus tools may not work, embedded systems can use whitelisting to ensure only authorized applications are executed. Integrity monitoring can detect unauthorized firmware changes. Physical tamper detection can alert when devices are opened or altered. Strong physical security is essential. SCADA field devices and embedded systems are often deployed in remote or publicly accessible locations. Use locks, sealed enclosures, and camera monitoring to protect critical infrastructure. Maintain clear chain of custody procedures for devices in transit or storage. Secure update processes are vital. Whether updates are delivered over the air or manually via a technician, the process must ensure that only signed and validated firmware is installed. Updates must be logged, and rollback options should be available if something goes wrong. Incident response plans must explicitly include SCADA and embedded scenarios. What happens if a field controller goes offline? What if an embedded sensor begins transmitting unexpected data? Plans must define how to isolate affected systems, conduct investigations, and restore safe operations without jeopardizing the broader environment. Let's wrap up with continuous improvement. SCADA and embedded system security cannot be a one-time project. These systems are long-lived, high-impact, and often under-regulated. Security must be reviewed regularly. Begin with policy reviews. Make sure your guidance reflects current threats, technologies, and regulations. If a vendor stops supporting a device, remove it from production or place it in a highly isolated zone. If a new vulnerability is disclosed in a widely used protocol, take immediate action. Use incident analysis to identify weaknesses in system design, monitoring, or response. If an incident occurs, learn from it, adapt your controls, update your training, improve your response time. Cross-functional collaboration is essential. Engineers, operations personnel, cybersecurity staff, and third-party vendors must work together. No single team can secure these environments alone. Training is a constant requirement. SCADA operators must understand how to identify anomalies and report issues. Engineers must understand the security implications of their designs. Security professionals must stay current on industrial control system threats and embedded vulnerability. Finally, stay proactive. Join industry groups, participate in information sharing communities for critical infrastructure, monitor government alerts and vendor advisories, develop a culture where operational resilience and cybersecurity are not competing priorities, but complementary ones. Thank you for tuning into the CISSP Prepcast by Bare Metal Cyber. Visit baremetalcyber.com for additional episodes, comprehensive CISSP study resources, and personalized certification support. Strengthen your understanding of SCADA and embedded system security, and will consistently support your journey towards CISSP certification success.